Our solar system is extraordinary. Of course, it was recently discovered that it rains solid diamonds on Uranus and Neptune. Uranus and Neptune are two of the gas giants within our solar system. On Uranus and Neptune, scientists forecast that there are rainstorms of solid diamonds. The gems, called diamonds, normally form in the hydrocarbon-rich oceans of slush that swathe the gas giants' solid cores. Scientists have long speculated that the extreme pressures within these regions might split those molecules into atoms of hydrogen and carbon. The carbon normally crystallizes to form diamonds. These diamonds were believed to sink like rain through the ocean until they hit the solid core. But no one could prove this. No one could prove that this theory actually works until this moment. In a recent publication in a journal, researchers say that they were able to produce this diamond rain using fancy plastic and high-powered lasers. Previously, researchers could only assume that the diamonds had formed. However, at this time, when they saw the results of their latest experiment, it was one of the best moments of their scientific career. Scientists have tried to do this before. Who wouldn't want to make it rain precious stones, especially rain diamonds? But they ran into difficulties modeling the incredible pressures near the gas giant's cores. Neptune and Uranus are 17 and 15 times the mass of our Earth, respectively, and their oceans are crushed by extreme pressures millions of times more intense than the air pressure at Earth's sea level. To match this intensity, the researchers and scientists used two types of laser, one optical and one X-ray laser, to produce shock waves. These waves were later driven through a block of polystyrene, a type of plastic composed of hydrogen and carbon, similar to what exists in the oceans of Neptune and Uranus. First smaller, slower wave was overtaken by another stronger second wave. The combination of the two waves squeezed the plastic to 150 gigapascals of pressure, more than that which exists at the bottom of Earth's mantle, and heated it to more than 8,500 degrees. At that very moment, the researchers and scientists began to watch as diamonds formed. The process lasted only a fraction of a second, and the diamonds were no bigger than a nanometer in length. However, the researchers and scientists were shocked to realize that the diamonds that developed on Uranus and Neptune would be probably larger and longer lasting than that which they managed to accomplish in their experiment. In the planet, you have years and millions of years and a long range of conditions that are perfect for diamonds to form. The results of this experiment will be extremely useful, not just for the understanding of the outer gas giants within our solar system, but for improving the process of making diamonds. It should be noted that most of these gems are produced in labs via a process called blasting, but the researchers suggest that through the use of lasers, it may be possible to produce cleaner and easier diamonds. Those stones can then be used for semiconductors, drill bits, and solar panels, not to mention instruments that model the conditions inside the very gas planets that inspired this research. Neptune and Uranus are extremely extraordinary. Many persons tend to combine Uranus and Neptune together in their thoughts, almost as if these two planets are twin worlds. They're nearly the same size, bigger than Earth but smaller than Jupiter or Saturn, and both of them are bluish or bluish-green, with deep atmospheres and icy interiors. But though superficially similar, Uranus and Neptune are really quite different. They are more different from each other than most people believe, and although their differences still haven't been fully explained, it now seems that mighty collisions with careening planet-sized bodies early in our solar system's history might be the key to this explanation. Uranus and Neptune are the two most distant known major planets in our solar system. Both are considered ice giants. Both are fundamentally different from the larger gas giants Jupiter and Saturn, and from smaller rocky worlds like Earth. It should be noted that Uranus and Neptune have similar masses and internal compositions. Their outer atmospheres are composed of hydrogen, helium, and methane, while their mantles are a combination of water, ammonia, and methane. Ices and their cores are a mix of ice and rock. Planet Uranus tends to have a blander appearance than Neptune and is mostly cloudless. It should be noted, however, that Neptune's atmosphere has darker bands than that of Uranus, with streaks and wisps of white clouds, as well as it should be noted that Uranus has a large dark spot. There are also more significant differences between the two worlds. Like Neptune and Earth and most other major planets in our solar system, Uranus doesn't rotate around an axis that lies nearly perpendicular with respect to the plane of its orbit. Instead, Uranus and its major satellites are tilted about 97 degrees into the solar plane, and the planet effectively rotates retrograde with respect to the Sun. Another critical difference is the larger moons of Uranus are in stable orbits that are aligned with the tilt of the planet, but Neptune's larger moon Triton circles the planet at a very inclined orbit. These key differences suggest that Uranus's moons formed from the same disk of dust and gas that the planet itself did, while Triton was probably once a separate object captured by Neptune's gravity. Like, comment, share, and subscribe. I really hope you enjoyed this fascinating information about Neptune and Uranus.